Bobby asked me a question about K sub R versus K sub T. Some of you may have seen those mentioned in one of your assignments. So instead of just like simply answering the question, I decided to go outside and have a little bit of fun with it. So here I am with my trusty little bicycle wheel. And what we're going to do is we're going to get that bicycle wheel spinning. And I'm going to ask you right now, at that moment in time, when it's just in my hand spinning, does that wheel have kinetic energy, yes or no? Because, let's see, let's just double check. We know that in the past, when we've taught about kinetic energy, we've used this equation, or something very similar to it, right? Kinetic energy equals 1/2 mv squared. And yes, that is supposed to be a squared. But it doesn't have a linear motion. It's not actually moving anywhere. It's just sitting there in my hand. Well, this is where it's helpful to go back to our general definition of kinetic energy. What is kinetic energy? It's the energy of motion. Since that wheel is in fact spinning, it has kinetic energy. That's where this term comes in. All right, that is the energy, that is rotational kinetic energy. All right, so let me get that out of the way. And let's refresh our memory here that, let's see, rotational kinetic energy depends on, what does it depend on? Well, it depends on the rolling inertia or the rotational inertia, the moment of inertia of that object. All right, the fact that wheel has some mass spinning or rotating around its center of mass, and its angular velocity. Since that wheel is spinning, it most definitely has an angular velocity, so it has rotational kinetic energy. All right, it doesn't have any of this stuff right now, but it does have rotational kinetic energy. Here's a question though, how do we know it has kinetic energy? Let's see. For this, we have to look at another definition. What is energy? Energy is the ability to do work. So if that spinning wheel in fact has some kind of energy, it should be able to do work if it's in the right circumstances. Well, let's see what happens here. So it goes from no translational energy to now it's moving. Okay, I want you to notice at this moment right here, what's going on. All right, if we break this down, we see that it is spinning like so. So it still has rotational kinetic energy. But at the same time, it's also, the center of mass of that wheel is moving in a straight line. So not only does it have rotational kinetic energy by spinning, it also has linear, or what's known as translational kinetic energy, by the virtue of that mass moving translationally, or in other words, in a line. So if we were to determine the total energy of that wheel at this moment, we would have to include not just the rotational energy, but also the translational energy. All right, and if I needed to, I could expand that even more into the terms that make each of those up. All right, or if I were to say, make energy charts, I might include terms for now not just general kinetic energy, but rotational kinetic energy, translational kinetic energy, as well as things like potential energy or gravitational, potential energy of a spring, etc., etc. So in this case, I would need to account for the fact that there is some of that and some of that. Now, if if I go back, before I let it go, when I was just holding it in my hand, it was nothing but rotational kinetic energy. And none of these existed. Once I let it go, there was still some of that, but now I have to account for at least some of that energy being translational. All right. And if I go back to an earlier question I asked, I said, how do we know that it has energy when it's just sitting there spinning in my hands? Well, the fact that when I sat it down, it started moving. All right. Well, that actually demonstrates a couple of things. It demonstrates a conservation of energy, because whatever energy it had, whatever rotational energy it had in my hand, is now distributed between those two types of energy. All right, and so that energy had to go somewhere. Now, what would be interesting, and I'm going to see if we can actually do this, is if we could kind of take a look at how fast it's rotating before I let go, and how fast it's rotating after it starts moving. Notice how the rotation slows down? What happened to some of that rotational energy? It had to go into moving it translationally. So, again, Bobby, I know that's more than you're asking, but I think this is a good review for everybody.